If you can't make out what's being said, please turn on the subtitles. When an object moves in a straight line, if we let A be the acceleration, v be the velocity, x be the displacement, and v0 be the initial velocity, the following two equations hold. Now, let's eliminate t from these two equations. If you'd like to try calculating this yourself, pause the video and give it a try. First, let's actually solve for t. This gives us the following equation. Substitute this expression for t into the expression for x. Substituting x into the equation gives us this expression. Next, we multiply this expression for x by 2a and simplify it. Now, if we multiply by 2a, we get this simplified form. At first glance, it might look a bit overwhelming with all these equations, but this is an important formula, so let's make sure we understand it thoroughly. The three equations we have looked at so far are essential for understanding uniform acceleration. Make sure you understand them thoroughly. We've also prepared practice problems to help you master these three formulas. Be sure to check out those videos as well. From here on, I will provide a more in-depth explanation. So far, I have explained the equations governing objects in accelerated motion, but now I will explain why these equations hold true. This explanation requires knowledge of the equations of motion and calculus, so if you have not yet studied these topics, please review them before continuing. Integrate both sides of the equation of motion. Integrating yields the following expression. Suppose that at time t equals 0, the object was moving with an initial velocity v0. In that case, the equation can be written as follows. This is why the equation for v holds true. Now, let's find the expression for x. If we differentiate v with respect to t, we get x, right? In other words, we can rewrite the expression for x as the derivative of v with respect to x. Also, to convert a derivative back to its original form, we just need to integrate it. So, if we integrate both sides of the equation, we'll get the expression for x that we're looking for. Now, let's consider the case where t equals 0 and the displacement is 0. Since t equals 0, substituting this into the equation for x from earlier determines the integration constant. The calculation shows that the integration constant is 0, so substituting c equals 0 into the equation for x completes the equation. If you're interested in physics, be sure to try solving some practice problems. I plan to add more practice problems to this channel as well.